Yes, there is a requirement to install a main disconnect on the primary side of the transformer. Article 450.39 of the National Electrical Code, or NEC, addresses this requirement. Specifically, it states that where a transformer is not readily accessible to the operator, a disconnecting means must be installed at the point where the primary conductors connect to the transformer. This provision ensures that a means to energize the transformer is available at the transformer location, enhancing safety during maintenance or in emergency situations. Article 450.59 provides additional details regarding the required characteristics of the disconnecting means. According to this section, the disconnect must be rated for the maximum current and voltage of the transformer. Furthermore, the disconnect must comply with the requirements outlined in Articles 404 and 408 of the NEC. Article 404 primarily covers switches, addressing aspects such as the type of switch, its voltage rating, and its suitability for the intended application. Article 408 focuses on switchboards and panel boards, covering topics like overcurrent protection, busbar arrangements, and conductor terminations. Given that the transformer is located 75 feet from the 480 volts panel providing feed for the transformer, it is deemed not readily accessible to the operator. Therefore, a main disconnect must be installed on the primary side of the transformer to meet the requirements of the NEC. The purpose of requiring a disconnecting means at the transformer is primarily safety. It allows for the quick and safe de-energization of the transformer in case of a fault, during maintenance, or in an emergency. Without a local disconnect, personnel would need to travel back to the main panel to shut off power to the transformer, which can waste valuable time and increase the risk of electrical hazards. Determining whether a transformer is considered readily accessible often comes down to local interpretations of the NEC. A general rule of thumb is that if the transformer is located more than 6 feet away from the primary power source and not within sight, it is considered not readily accessible, necessitating the installation of a local disconnect. The disconnect must be properly rated for the voltage and current of the transformer primary. The voltage rating of the disconnect should be equal to or greater than the primary voltage of the transformer. The current rating must be sufficient to handle the maximum primary current. To calculate the primary current, divide the transformer's kilovolt ampere, or kV, rating by the primary voltage and then adjust for the number of phases. For a 3-phase transformer, multiply the result by the square root of 3. The disconnect can be a switch, a circuit breaker, or other approved means of disconnecting the power. It must be clearly labeled to indicate its purpose and the equipment it serves. The location of the disconnect must be readily accessible and not obstructed by other equipment or materials. The NEC specifies several requirements for disconnect switches. Firstly, the switch must be horsepower rated if used to control a motor load. Secondly, it must be capable of interrupting the available fault current at its installed location. Thirdly, it must be suitable for the environment in which it is installed. For example, if the switch is located in a damp or wet location, it must be listed for use in those conditions. The NEC also specifies requirements for circuit breakers used as disconnecting means. Firstly, the circuit breaker must be marked with its interrupting rating. Secondly, it must be suitable for reverse feed, if applicable. Thirdly, it must be equipped with listed accessories for locking in the open position, if required. The installation of the disconnect must comply with all applicable requirements of the NEC and local codes. This includes proper wiring methods, grounding, and bonding. It is important to consult with a qualified electrician to ensure that the disconnect is properly installed and meets all applicable requirements. Failing to comply with these requirements can result in electrical hazards, equipment damage, and code violations. Therefore, it is essential to take the necessary steps to ensure that the disconnect is properly selected, installed, and maintained.